We're going to name compounds. There are going to be two parts. In this part, you should already be able to name simple compounds, but we're going to make sure you can name all binary compounds. In our next part, we'll talk about ternary compounds. So the question of the video is, how can we distinguish between the chemical names of fool's gold or pyrite on the left from this black sludge made up of the same elements? They're both made up of iron and sulfur. So, binary compounds consist of only two elements. To name, you're going to write the complete name of the first element, and the second element will end in IDE. For example, sodium chloride, potassium iodide, magnesium chloride, and calcium nitride. What you can notice is it doesn't matter how many of those elements there are in the atom form, it matters that there are only two elements total. When naming, always name the positive cation first and the negative anion last with that IDE ending. You might want to pause the video here to see if you can get these right, but we get lithium phosphide, aluminum sulfide, strontium bromide, rubidium oxide, barium selenide, I missed one there, and cesium iodide. Problem. FeCl2 and FeCl3 are different compounds but seem to have the same name. How can we name them differently instead of just both be called iron chloride? Well, FeCl2 is going to be called iron 2 chloride, and FeCl3 is going to be called iron 3 chloride. The 2 and 3 might seem like they're related to how many chlorides there are, but it actually is related to what the charge of the ion is of iron. So the Roman numeral is in regards to iron's charge when it mixes the way it does in these chemicals. It's similar to your name. Your middle and first name are kind of connected. Like if I was ever in trouble, they're like Kristen, Judith, right? Not your middle and last name. How often are you called by your middle and last name unless it's an exception? So again, the Roman numerals represent the charge of the transition metal you're working with. Transition metals are in the middle group of your periodic table from scandium through zinc and down. The nonmetals on the right side of the staircase can also use Roman numerals if they're the cation, because they have multiple charges or oxidation numbers, and you want to show the charge or oxidation number you're using. You should also memorize the Roman numerals in order of the dashes that we have here. General rule is the first elements in the first column are +1, the second column are +2, aluminum's column or boron's column is +3, carbon's column is +4, and then works their way down. Nitrogen's column is -3, oxygen's column is -2, fluorine's column is -1, and then we have the noble gases at 0. This rule does not always work for cations, so you're going to have to follow the anion charge and equalize that charge with a cation charge, make them equal to 0. So looking back at FeCl2, we knew that it was called iron 2 chloride, but that's because chlorine's -1, and there are 2 atoms of chlorine in that substance. So they have a -2 charge. Iron's +2 will counterbalance that charge. In CuF, F is also -1 because it's also in the same group as chlorine. In order to cancel the charge, copper has to be +1, so it's copper 1 fluoride. Oxygen in zinc oxide is -2. You might have thought you're going to write zinc 1 because you were thinking how many, but it's the charge. Zinc has to be +2, so we're going to call it zinc 2 oxide. But it turns out zinc only forms +2 ions, so we actually don't have to say which one it is. But if you wrote zinc 2 oxide, you would not be marked wrong. Nitrogen actually forms multiple charges, so since oxygen in this compound is -2, and there are 3 of them, and we have 6-, we need to have each of those nitrogens add up to 6+, so each nitrogen is +3, and so nitrogen 3 oxide. Again, sulfur normally is -2, but oxygen's also -2, so they can't be both minus. So oxygen's be the -1, it's going to be -2 times 3, so 6 minuses. So sulfur is going to be +6, sulfur 6 oxide. Chlorine's -1, there are 3 of them. The phosphorus is going to be +3, so phosphorus 3 chloride. Last hydrogen in the back is -1, there are 4 of them. So carbon's be +4, carbon 4 hydride. Notice again, they all end in IDE, and the Roman numeral represents the charge of the first element. We're going to go backwards and give the formula. So I would look at the charges of each individual part. Since potassium's in group 1, it's +1. Iodine's in the back in group 17, it's -1. So this is going to be K1I1 or Ki. We don't write ones, we usually drop them. Magnesium's in group 2 +2, and chlorine's again in a halogen at -1. So now we'll need 2 chlorines to match the charge of magnesium, so we're going to say MgCl2. Aluminum is +3, and sulfur is -2. They can't be equaled out by just having 1 of each or 2 of each, so you're actually going to need 2 aluminums to be +6, and 3 sulfides to be -6, Al2S3. If you're getting the hang of it, I would recommend pausing the video and then checking your work. Hydrogen is +1 when it's in front, oxygen is -2, so it's H2O. No surprise there. Barium is +2 and selenium is -2. This is a perfect match. We don't need any extra. It's just BASE. Cesium is +1, phosphorus is -3. So we need 3 cesiums to catch up with phosphorus's charge. Strontium is +2, phosphide is -3 like we just did. This time we'll need Sr3P2, kind of opposite of the Al2S3 example. They're telling you the charge of copper. So copper is 2. You don't even have to look it up. And fluorine's -1. So we get CuF2. And last, again, they're telling you the charge of iron, which is +3. And tellurium is -2, Te. So we're going to get Fe2Te3. Back to the question of the video, how can we distinguish between these two chemicals? Well, we'll need some Roman numerals, right? They're not going to be both iron sulfide because then that would be really confusing and one is completely different than the other. So if sulfur is -2 on your reference table, then Fe is going to be +4 here, and we're going to call that iron 4 sulfide. In the sludge, again, sulfur is -2, but there's only one of them. So iron's going to be +2, and that's going to be iron 2 sulfide, so you know which one you're working with. At this point, you should be enabling all binary compounds.